Hi, I'm Stanley here. I'm gonna demonstrate about our Team 10 applications. But first, I will explain a little bit about our current system architecture. We divide our services into four big categories. The first one is the producer-consumer part. The producer-consumer part will be used on the recurrent harvester. So we have the first component here, which is the publisher. The publisher will took the data coming from API, so it will scrape the data, and they will send the data into our message queue, which is the RabbitMQ queue, and our RabbitMQ queue will store the data, and our consumer, which is our subscriber here, will subscribe the to a specific topic from RabbitMQ queue, and they will send the data into Elasticsearch. So our publisher here will be triggered by Vision by using the time trigger feature from Vision. And for the subscriber or the consumer, we will use the Vision MQ trigger. So the MQ trigger will spawn a key scaled object, Kubernetes event-driven autoscaler scaled object, and it will watch the message queue, the RabbitMQ specific topic, and it will automatically scale our consumer based on the traffic into the topics. And the second one is we have the harvester here. We have, it's kind of similar with the recurrent harvester, but the different part is on the publisher part. The publisher here, we will use the Kubernetes job. It will take the data from a given range of time. So it will be used to backfill the data for, let's say, we have the system down and we want to backfill the specific data from a range of date. We will use this Kubernetes job. It's the same. It will send the message into MQ, and we will have the consumer, which is like the Mastodon consumer or Blue Sky consumer, subscribe into a message queue and send the data again into Elasticsearch. And the third one is about how we made our application, how we can communicate it between the front end, back end, and the database. We will use the HTTP trigger here from the Vision. So we will develop a backend API that will uh, communicate communicate with Elasticsearch, and the front end here will communicate with the backend API. So instead of front end directly communicate into the Elasticsearch, we will have a mediary between using the HTTP trigger in the Vision. And the last one is how we can develop our sentiment populator here. So the sentiment populator is we have a service where we will populate the data from the harvester. So we will add a sentiment score for every data that we have. So we have sentiment populator here that will directly connect into the Elasticsearch, and it will triggered by a Vision time trigger as well. Okay, and now we will start to demonstrate about our application. So as you can see here in our backend, we have several applications. The ad hoc one, the ad hoc is, if you're looking back again in these diagrams, it's the ad hoc harvester, the ad hoc one. They're using the one that using Kubernetes job. And we have the Blue Sky API as consumer, the recurrent producer, sentiment populator for the Blue Sky and the Mastodon source of data. But first, I will demonstrate a little bit about our application that already installed here in our cluster. We have Vision that, yeah, same as the one that explained in the workshop, Elasticsearch, Kibana, and the one that we add here is the RabbitMQ and the Kubernetes dashboard. Let's start from the Kubernetes dashboard. We can take a look at this part. By installation, we already have installed in our cluster. And let's connect into our Kubernetes dashboard. First thing, we need to create the access token here. Creating the access token, we can copy task token and let's say save it here. And let's connect into our Kubernetes dashboard by just port forward it from the Kong proxy here, from port 443 into our localhost 8443. And we can put the token here. And as you can see here, we already have the several namespace. The default is where our Vision applications are. The Elastic is where our Elasticsearch located, and also the Kibana. And we have the KEDA that are installed together with the Vision, Kubernetes dashboard, which is this dashboard. The RabbitMQ, we currently only use one RabbitMQ because we want to make our application can be scaled more. And util is where we usually run our ad hoc application, and we have stored our shared notebook, the Jupyter Lab share. So let's start first from our application, several backend application here. Oh, sorry, I will start. Let's take a look at our RabbitMQ. In the RabbitMQ, they have the built-in UI in the port 15672. Let's take a look at this port, and you can see I will fill the username and password first, and we can see here we have one exchange that we will use for the harvester, and we have the queues here for the Mastodon and also for the Bluesky, and we see the Reddit queue here, but we didn't use it anymore. And let's see on our application currently. Let's take a look at the Vision package here. We have several packages here: the Bluesky Sentiment Populator, API Mastodon, API Consumer, and etc. And let's see on the function here, they have the same as the package, the name. And we also separate the environment for our application for the HTTP uh, which is the backend API, and also the environment for our publisher and subscriber application. So basically the harvester. So if we can see here, let's take a look again in our dashboard. Default. We have several pool manager here. 1, 2, 3, 4, 5, 6, 7, 8, 9. Which means we have the Python API here. I believe it has 3. Let's take a look in the terminal. The pool manager Python API has 3 because we set the 3 pods to already warm up. And also there are several pods here for the Python default here, which is for our subscriber and consumer. It's not 3 anymore, even though we set it 3 for the warm up because it already scaled up, because previously I believe the application already run for our service already run, for example, like the harvester for the Mastodon. Because if we see here, we have 4 time triggered application: the recurrent producer, the sentiment populator, and for Mastodon and for the Bluesky, which is running every hour. The first one is running in minute 0, and the second one is running in minute 5. So if we want to see like the scaled up application here, how can we dynamically scaling let's say for our traffic, let's try to run our recurrent harvester vision event list, which is, for example, we want to run the recurrent producer for the Bluesky. And let's take a look on the log for that application. Let's say previously the Bluesky recurrent producer here, vision function logs. Okay, it's already running. And I believe if we take a look at our RabbitMQ here, it will send the data into the RabbitMQ queue, which is the Bluesky queue here. Let's change the time series into last minute. It's sending with the rate, I think it's about 10 per second here. And let's take a look at our post here. Now, you can see here, our application is being scaled. I'm sorry. Okay. Let's take a look. I believe the Bluesky ES consumer here is being scaled up. FN pods, the name is Bluesky ES consumer. Look at this. There are a lot of instances because the traffics are coming into this queue, And because the rate is pretty high, which is around 10 messages per second, it will scale up into a lot of instances to consume the messages inside it. And let's take a look at the pods currently, the current state now. Previously, the pool manager Python default has 6 pods. Now I think it's more than 10 pods. And you can see here from the edge is recently spawned. For example, like previously 6 seconds ago, 13 seconds ago, and the other one, I think this is the old one, the 51 minutes, 54 minutes. This is the 51 minutes before. And I think we can take a look also on our application, the front end and backend application. Here we already have uh, the Jupyter Lab port forwarded into our local. We already have the Jupyter Lab shared in our cluster. Sorry, I need to reload it. And let's take a look at this front end. For the Mastodon, we can hit this router for vision endpoint for the HTTP trigger with Mastodon and getting the get post per day for attacks AI and privacy, for example. And if we take a look at the data will be look like this. Sorry. We have the data, we have the X value, X field, and I think we have the Y field here. Yeah, we also have the Y field here for the Mastodon API. And if we want to take a look at the code for the Mastodon API here, we have the functions and the query. Where in the function we will have the gateway. The gateway here is the one that being sent into our vision function. So if you can check here, the entry point for the vision function here is the functions.gateway. So for the function.gateway, it will map into another comment here, and it will also take the query arguments from the URL. For example, here in the query argument is text, and taking the get post per day, which is here, and it will perform the adapt query for the corresponding tag, and it will perform searching for the specific query, and it will just retransform the data and returning into the as a response and return this value as a response. And for the ad hoc application, we will use the job here. For example, we will use, sorry, this is already, I will take a look at the Blue Sky producer here. The job here, we have the Blue Sky harvester. We build our Docker and we push it into our Docker registry. And let's try to running the ad hoc Blue Sky producer here. Ad hoc Blue Sky producer. But first we need to check here in the util namespace. Previously we have the ad hoc Blue Sky producer. Okay, I think it's not here anymore. Okay, let's start to make the job here. Previously we need to make the config map, but the config map we have some things that are quite confidential here. For example, like the Blue Sky user and the Blue Sky password. So that's why I already applying a config map in advance. So let's just try to run the job.yaml here. We can kubectl apply -f manifest job.yaml. Okay, let's take a look at the jobs here now. And util, it will have the ad hoc Blue Sky producer. The status is running. And let's take a look at the pod. We have the pod is running too. Let's take a look at the logs. kubectl logs and util. Okay, start to run. And let's see again in our RabbitMQ. Okay, it's already hit the RabbitMQ as well. Because the RabbitMQ message rate here, if you can see, it's going up instead of 10, because previously we running the producer from the recurrent producer from Blue Sky, and it started to going up as well into around 20 messages per second. Yep. But I think for now we will delete it for the job, because I think the RabbitMQ will be quite burdened by having a lot of traffic going in. Let's start to delete the jobs here. Let's take a look at the job. From the ad hoc Blue Sky producer, we need to delete the job here. Okay, I think I forgot to mention a little bit earlier about the Elasticsearch data here. So, especially about the process of the consumer sending the data into Elasticsearch, is it success or not previously? So we will test it against the Blue Sky V3 index. So we will test the Blue Sky. Let's try to run the Blue Sky recurrent producer here. Okay, should be running now. Okay, it's running. And previously, in the total data of this index is around 1.46 million. So it's already running, and let's take a look at the RabbitMQ. Also already consumed as well. We can try to take a look. We just count it, and okay, you can see it's increasing the data. Let's try to run it again. It's increasing, and should be always increasing. So let's try to take a look at the data, how the data look like. So the data look like this for Blue Sky V3 data. It has the URI, CID, how the author, and what is the record content look like. You can see the created at here is the record created at 17th of May. And let's try to take a look at the newest data. I forget the query. Let's take a look here. The newest data. So the newest data should have at least the created at is on 20th of May. Record dot created at here. The order should be descending. But let's just take a look at the source of it is the record dot created at. Okay. Okay, it seems some of the data is from the source of data. The Blue Sky data is having a little bit of dirty data here. So because as you can see here, the created at is on 25 May, which is in the future. It's pretty funny too. And you can see here we already run it like at the now it's around 14:45, 14:46. We have the data of 20th of May. The created at here is in UTC, so we need to add around 10 hours. So we have the data at 14:43. So basically it's like around 3 minutes ago. So the data is already coming into our Elasticsearch index. And let's try to count it again, yeah, just in case. We have the around 1.46 million data around that number. That's a lot of data. We can also take a look about our Mastodon data. The Mastodon data is on only around 200,000 data, but let's take a look at the structure of it. It has the ID, the URI, the URL, the account details, the content. It look like this, and the created at data, and many things now, like the text here. Since we have a lot of applications here, I don't think we have enough time to demonstrate everything, but I think I will brief a little bit about other application. For example, like the Blue Sky Producer before, it will running in a Kubernetes jobs, and it will send the data, the messages into RabbitMQ. And g- going to the second one, this is the Blue Sky Sentiment Populator. It's similar with the Blue Sky Producer, but the difference is instead of sending the message into RabbitMQ, it will directly this application will directly update the fields in the Elasticsearch. For example, here we can take a look. The action is update for the specific index and the document ID from the document ID X, and it will update a sentiment score string. And for the ad hoc Mastodon producer, it's similar with the Blue Sky producer, but instead it will just use source of data is from the Mastodon instead of from the Blue Sky. And for the sentiment populator is similar for the Mastodon in Blue Sky. And for the Blue Sky API, it's similar with the Mastodon API, which is we have the comment mapping here. And we take the arguments, the query arguments. And next is the AS consumer. It is the basically like the subscriber, the Elasticsearch consumer for the Blue Sky. It will basically like the parsing the document and insert it into the Elasticsearch. After that, we have the Blue Sky recurrent producer. It is quite similar again with the ad hoc Blue Sky producer, but instead of running in Kubernetes job, it will running in Vision time trigger. It will trigger by Vision time trigger, I mean. And after that, we have the Blue Sky sentiment populator. It's similar again with the ad hoc Blue Sky sentiment populator. Instead, it will run in the Vision time trigger as well. And the Mastodon API is the same with the Blue Sky API. When the Mastodon as consumer, it's the same with the Blue Sky as consumer, which is just the difference, just the index that the AS will be, and also the parsing document logic. But for the Mastodon, we didn't parse the document; we just directly insert it into our Elasticsearch. And the Mastodon recurrent producer is the same with the Blue Sky, but it will take the Mastodon data. Sentiment populator also same with the Blue Sky sentiment populator. And I think that's it about the our backend applications. And let's take a look about the with the front end application here. We have the shared notebook. We will use that, which is this in the NUT namespace, the port 8888. Let's refresh it. We'll take a look at here. We have, like the previous explained here, we take the data from the backend API, and we will take the data and we generate the chart here. We have a lot of charts here for Mastodon, and also we have uh, different notebook for the Blue Sky. Then just the difference is only the data and also the several visualization inside it as well. Because in the Blue Sky we don't have text, so it will be a little bit different with the Mastodon front end. But in the Blue Sky we have a lot of data instead of compared to Mastodon. And I think that's all about this demo. And I hope it all covers everything. And thank you.